Hello, everybody. Welcome to Tertiary Courses, Features and Introduction to Time Series in R. So, for all of us here, what is time series modeling? Now, time series modeling is a statistical method used to analyze patterns and trends in time series data, usually to extract insights and statistics to understand how the data moves and changes across time. So, this has several applications and usefulness for businesses and industries alike. So why do we study time series modeling? Simply because there are many ways we can analyze the data. Descriptive analytics, for example, to determine trends or patterns in the data, cyclic pattern, overall trends, spectral analysis, where the certain frequency of certain events do occur. Okay. Forecasting is meant to understand that using the particular patterns in the trends to forecast ahead, probably in the next 2 months or 1 year, what the business or sales will look like, to understand trends in the data and project into the future. And another one is anomaly detection, where we use to identify differences, deviations in the data, understand why do these strange events occur or extreme events occur, and looking at the data, we can predict such events if they occur in the future. That is an example of outlier detection or anomaly detection. So, what are the benefits of time series modeling? First of all, intervention analysis is to understand if an event can lead to a change in time series. If I were to adjust this factor, does it affect the time series at all? It helps me to understand how the data works. Explanative analysis to look at correlation or relationship between two different time series and the dependency on one another. Now, time series, basically, there are three major components of time series. Firstly, there's trend. The trends exist when the time series increase or decrease at a constant rate. There is no trend when we cannot understand the patterns in the data. There's no clear direction in data. So a trend will understand if the time is going up or going down at a constant rate. Secondly is seasonality. Now, perhaps the time series always peaks at a certain month, for example, February. So we notice that the time season go up and down, but always peaks at a certain period in a year or certain day in a month. So this is follows the concept of seasonality, where a time series has a particular pattern based on the time frame. Last concept is basically cycles. Now, cyclic seasons, they do not occur at a fixed rate. For example, they kind of adjust based on the different months or different years, but cycles is definitely a component of time series. Now, I'm going to open up my R Studio. As you can see, this is the script that to show display to you the value of time series. So, first of all, we're going to use the air passengers dataset. Now, what is this dataset for those who aren't familiar? This is basically a data set of airline passengers from the year 1949, 1960. Now, to look at the data set, I just look at the raw data set for you. So, this data set is very simply a data set for 1949, 1960 for every single month in the year. All right? Okay. So, if I were to look at the class of the time series, it is actually a time series class. Very simple to plot the time series. Just plot TS and you get the time series from 1949 to 1965, 1960. Now I'm going to teach you how the decomposed function, which basically breaks down the time series into individual components I was talking about just now. This is the observed time series. This is the upward trend, as you can see. These are the seasonal patterns, as you can see over here. And over here, random is the noise that's generated from the time series that's unexplained by the algorithm. So there's this package called TS Studio, which is very useful for plotting time series graphics. Let me show it to you. Again, some plots like TS plot. Again, we use it to get a basic time series as usual. MA stands for moving average, which shows you can see here the moving average of the time series as it goes along. Okay. Heat map is also another useful function. You can see from here that the peak periods occur within June and July and June, August, September. These are the peak periods. And the past few years, so 1959 to 1960, has been a more darker blue, so it's more passengers around this time. You also have the seasonal, where we can look at every independent individual year. We can see how the times we speak. We can notice that usually the months of July, August, September are the peak, and that over time the number of passengers have been increasing steadily. Also have the decomposed function, as you can see, okay, where we again break down data into individual components of trend and season. You have the month plot, which plots not by year but by month. For every month of January, February, the data is increasing over time. And we have the box plot, which also shows that this part month, June, July, August, September, are the peak periods where the time series tend to peak, where the passengers tend to come travel along this time. Okay, so this is all I have for you today, guys. Thank you all for watching and hope to see you next time.